Gordon? 1.2. Grade, angle, elevation, distance. Let's take a look at this. Hello. So, with this, be quick on the draw. What does it mean? Squares, first of all. This should be reviewed, something you should know. You should, when you need to square a number, multiply it by itself. What does that mean? Well, 5 times 5, that's 5 squared. Often there's a square button on your calculator. Use that. Now, it depends which calculator you use, but usually it's an x squared button. What it does is 5 squared, which means, okay, and touch, which means 5 times 5. Well, you don't actually have to type in 5 times 5 for 25. Find your x squared button on your calculator and hit 5 and then the square button. Yep, right now. Or get a calculator if that's the case. First. Bucket. Now, then, can you guys quickly do, it works with decimals too. 1.3 squared is, get her down and you tell me. Okay, what's that? 1.69. So you just got a text about Tatiana? 1.69. Okay, now this one here. I made a little mistake here, but the square root of 5. Well, let's do this. We'll use what's here. It's a decimal number. That's not a very good one here. I'm going to just tell you what to do here. Just ungroup. I'm going to give you, can you guys write in 25 in there? There, that's what I meant. This one works way better than what you currently have. So I don't want to confuse you with decimals too much. Okay. Square root. This is the next review. A square root is the opposite of a square. Use the square root button on your calculator to undo a square. Now, this check mark, square root symbol, means what number multiplied by itself makes 25? What times what makes 25? And your answer is 5. Get that button though on your calculator and see how you do the square root of 25. Make sure you get 25 when you try this. So find the square root button on your calculator. It's different on every brand. Often it's the second function of the x squared button. Sometimes it is a totally different button. Yours is a check. Okay, the white one has a check. 25. Try it out. Oh, you got that. Get, what's that? Yeah, get used to using, you can't use your phone on a test. You know, so don't get used to using it. Okay, how about this though? You know, I say, hi there. We're just getting started on this stuff here. First page of this started. Thanks for sending a message. I was about to send out a search party. Worried about it. Not. I wasn't. We just get to know me a bit. Come here. I got something for you. This section. Squares and square roots, you remember that? A little bit? Okay, that's what we're reviewing right now. Okay, getting back on here, and I'm recording, right? So, Justine, you need to be on task. You really do. If x squared is equal to 1.69, what is x? Huh? Now this is different. How do you undo a square? Square root it. So if x squared is equal to 1.69, how do you find the letter x? 1.69 under the square root sign, which is, like you said, 1.3. Your calculator could tell you that, but I purposefully picked two examples that were, you see how the examples I picked were mirror images of the previous examples? 25 and 5. Okay. Just so that you could understand how they are opposite of each other. Bless you. Now, moving down. Review the Pythagorean theorem. Math 10 last semester with Ms. Rogers. Did you guys do this one? Pythagorean theorem, a squared plus b squared equals c squared?
Oh, yeah.
Yeah, you did. See? She said so. I'm pretty sure you did. I thought you guys did, but maybe not.
I don't really know.
Okay. She says you did. She knows everything.
Yeah.
Okay, back to me. Here it is, a squared plus b squared equals c squared. It's something people do in grade 9 often, but if you don't remember grade 9, that's fine. You'll remember it grade 11. Now, what do I mean by a squared plus b squared equals c squared? If you label your triangle, the sides are the small letters, A, B, and then C. And it has to be labeled a certain way, and I have all these different things. C has to be what we call the hypotenuse. C is always the side that's across from the right angle triangle. This is the C, this is the C, this is the C, the hypotenuse. And you guys remember the word hypotenuse from your sine and cosine unit, right? You remember what I'm talking about, Tatiana? I don't know. But the side across from the right angle, we call it the hypotenuse. But have you ever seen this formula before? Okay. The C has to be the side across from the right angle. So that's what I'm saying there. A and B are always attached to the right angle, A and B. It doesn't matter with A and B if you switch them around, but it does matter with C. Now, solve for X in each diagram. I'll do 2 of them with you, and you'll have the tools to solve most of the problems. Let's, on this diagram, before you start it, take your pencil and just label A, B, C. Hi, Callie. I'm going to go A, B, and C like this, okay? Why am I doing that? Well, I'll show you in a second here. Just getting you set up, young lady. So, we're at the bottom of that page, EBC. So with this one, I want to just know, and you do too, which one the C side is. That's a really important thing, because this formula only works properly one way. When I take this formula, and just a second here, kind of just do this to it. When I take this formula down here, and I replace, what's my letter A? What's the number I have for the letter A to put in A squared instead? 12 squared, right. I go 12 squared. Plus, instead of B squared, what do I put down? 5 squared. And instead of C squared, what do I put down? X squared, or whatever. It's my unknown, right? You could keep it as C. I'm going to put it as X because that's the black letter that I have there. Squared. Do the arithmetic on the left side using a calculator. Dearie, I'm going to bring you a calculator, okay? It's 12 squared plus 5 squared. Tatiana, do you need one too? Yeah. Pretty close to an eyelash. Okay. Got a little draft in here. On your side, open up your window. Okay, good for you. Now, so 12 squared is 144 plus 5 squared is 25. You don't have to always write these out, but I'm gonna. There's nothing you can do to the x squared yet. Then you have to put them together. Is that one crap? You know, that's the second time. Take the old blue boy there. I'm going to throw this mother out. Okay. 144 plus 25. That's what your button should tell you. Write the steps down. Too many shortcuts, you end up getting stuff wrong, and I know it happens. 144 plus 25, and it's 469. 169. I'll wait till everybody's at this point, because they're not done yet. Doozy. How? Okay. I'm going really fast. I'll wait. You good? Do we have, is everybody caught up with me on here? I'll make sure, because I know some people are just, at the back you are, right? Are you caught up with me? Making sense with what's going on? And I'll just give it a minute. Does this make sense to you, Tatiana, or not? Okay. Should I check in with you in a second? Okay. Everybody else, if you're, or even you, we have 169 equals x squared. How do you undo a square? Square root it. Okay. So this is where you take what we were practicing above, hit the square root button. I'm using black for the buttons. 169. That's going to give you the single letter x. That solves for x in that diagram. Now, I'm going to just quickly zip over here because that calculates new to you. Oh, okay. Well, let's see. What do you want? 12. First. Oh. So you knew now what to do? You good? Keep asking questions. The other one is different though. This is where you got to be careful. This is why labeling A, B, C is so important. Now, we're going to use the same formula down here. Look at the diagram before we started. Can you guys label where the C is? The A and the B don't matter as much. The C is always across from the little square, the right angle. So this has to be C. You can't choose it any other way. Whether or not you put A here on the other side that doesn't matter. So I'm going to just call it A, B, C like this. If you had it the other way, A and B switch around, that's just fine. Now, in my formula, instead of the letter A, what do I replace it with? X. Right. B. Instead of the letter B, Tatiana, do you see the connections here? What would I put in for the letter B instead? The 3.0 squared. Yeah. I'm going to just do that, as you said. And then the C is the, Justine? Not sure? Okay. You got to be paying attention here. Okay. 3.3 squared. Now you got to do some arithmetic on your calculator. X squared is going to be x squared, but I got to figure out some other stuff. I'll do it with you real quick. 3 squared is going to be 9. 3.3 though is what was that? 10.89 I heard you say? Chain of the brainer. Now, this is a little different than the other one. Do you see why? The x squared is mixed up with this number. If you're adding 9 to x squared, what's the opposite of adding 9? Subtracting 9. This is that algebra stuff. We're going to mix some things up here a bit. So here's what I'm going to do. I'm going to squeeze this in here. If I have add 9 here and I want to get the x squared all by itself, I'm going to say minus 9 here and minus 9 here. Why? Because I want to get x squared by itself. So squeeze in a little minus 9 there and a minus 9 there and do the arithmetic on the right-hand side. Ten minus 9 is 1, then 0.8. I did the arithmetic for you. You got to check it. So keep going. You're good. Now, at this point, you ask yourself, it's x squared equals 1.89. How do I undo a square? Square root. Use the square root button. 1.89. You know what? I forgot to write down our answer on the previous problem. You get 13, and we call it centimeters. Okay. What is 1.89 square root? I'm sorry? 1.37, okay. That sounds reasonable. Yeah, don't go for it, because the decimals go forever. Always round off to about the same as what you started with. 1.37. Definitely don't go, there's like a bunch of 4s after that, isn't there? 4, 7, 7, 2, 7, 0, 8, yeah. That's plenty. And what was this in? Is it in centimeters? Nope, look back up to the diagram, it's meters. Now, you guys follow this? It's tricky. What I'm going to get you guys doing is set you up for Monday so that I can work with the workplace 30 people. So I'm going to show you a few more things. But I'm going to wait. This might be out of practice. Let's see. Oh, I just stopped the bias. 3 squared. You just go like this. 3 squared. That is plus 9. 3 squared. How about we replace that with a decimal? Just trust me on this one. When you hit 2.3 squared, start out as 10.8. 10.8. Now, did you hear what I meant by see how this x squared isn't alone? It's added 9. Squeeze in subtract 9. This all by itself. This makes some sense if you've done that kind of before. Okay. And then, so you only got x squared on this side. Equals. Then you just check on the square root. So that x equals 7. Does that make sense? Okay, yep.
So factorization, can I use the 2? Like that, factor 2? Can I use the 2?
You can't use the trick. Okay. A little bit of reading about this first. In the first section, remember how we said slope is rise over run? That's what that was about. I'm on the second page, Shayna. I know you want to pay attention too. So, I want to show you something on this triangle here. On this triangle, XYZ, Z, I guess we're Canadian. We say the slope of this angled line, the hypotenuse, is rise over run. Well, does it make sense that the rise is x and the run is y? Okay. Now, think of this as far as triangles are concerned. If this is my angle, x, right here, right? SOHCAHTOA. Did you guys ever say that or anything like that in grade 10 in math with Ms. Rogers? You guys, whoever you have. Sine, cosine, and tangent. Now, I have it up here, so you don't have to memorize it. But tangent is the opposite over the adjacent side. You'll have access to that formula every day that you're in my math classroom. I won't hide it on tests. That means the tan is the x over the y side. Opposite over adjacent. Now, there's nothing to write down here. But what this is telling us is that, do you see how the tan in this on a right triangle is the exact same as the slope? Okay? So, tan is the same as slope in this on a right triangle. So write this down beside here. Same as slope in this case. Okay? That's what I want you to get out of this. Tangent, don't do that. Now, there's a lot in this section. Let's find this. Find the tangent of the indicated angle, give your answer as a fraction, then a decimal. To the 10th position, 1 decimal point. Now, first of all, we won't worry about slope or anything, it just happens to be, though. The tangent of this z angle, opposite over adjacent. The opposite side is 5, over the b side is, like what's beside it, the adjacent side is 12. So what I say is that it's 5 out of 12. Okay, now do you guys see that connection? That's what it is, and then you divide it in your calculator. 5 divided by 12 is really what the fraction means. I'm going to round the 666, goes on forever, I'm going to round that up to 7. Proper rounding is necessary. Can you guys do the tan of what we call theta? Oh, that's right. This thing here, so the opposite is 12, the adjacent is 5. It's the same triangle, I'm just asking you for the other angle. Okay, so go for it right now. Tan is what over what, and then give me a decimal number. Oh, I set to 1 decimal place. That was my own mistake here. I should just have 0.4. Back there. So this one. Let me just check you on some. Oh, okay. It's 2.4. Good. Did you have 2.4?
Oh, yeah.
Okay, good. We'll flip it ahead a bit. Then, angle of elevation. Let me just see. Then we're okay. Good. Only a little bit left to do. Angle of elevation. This is working with tan to go backwards. Justine, you really need to pay attention. Find the slope of the hypotenuse as a decimal to the 3 places, then use it to find angle of elevation. Okay, this is a ramp. Right here, right? So how steep is it? What's the rise over the run? It's the same as the tangent. But here's what we're going to do. The slope is the rise, 6.8, over 4.2. And then you're going to use that to get a decimal. 6.8 divided by 4.2. This is always, these are the steps you always do if you have to get angle of elevation. Decimal to 3 places, 6, 1, 9, 1. Now there's a reason why you want a few decimal places. I'm going to stop first. Do people see how I found the slope? Rise over the 4.2, which is the run. That's where the numbers came from. Sideways is called the run, up, down is called the runs. Now, the next thing you do is just remind yourself, slope is the same as tangent of theta. That's just what we just learned on the previous page. So I'm going to rewrite this to remind myself, tan of theta is 1.619. That's a reminder because it helps with my next step. Now, I'm going to read what's underneath there. So no work done. To find the angle of elevation, that's the theta right here, like 30 degrees, 32 degrees. Use your calculator's tan minus 1 operation. It's usually the second function or shift, and then you hit the tan button. Now, we're going to try this out. So here's what you're going to actually type in your calculator. Depends which order you do this in. Some of you will hit shift or second function tan, and then 1.6. I'm saying it backwards. I gotta just write it down first. 1.619. Other people with the white calculators, you have to type in 1.619 first, and then hit second function tan. And then second function. Okay. Now, we've got, I think, 58 degrees. Where'd you go? They're not, okay, you got to make sure too that you're on degree mode. And PRG. Grade, not degree. This will work this time. If you're not getting 58 degrees, you're not on degree mode. Yep. Oh. See this graph. Degree. Try that 1.619. The second function, second function, yeah, and then oh, you mustn't hit it hard. Do it again. Good. There. Okay, is it 58 degrees, folks? Somebody else confirm what she got? Oh, come on, you're terrible. Is it 58 degrees? Yeah, okay. 58 degrees. That's what you're doing on one of those. You can flip back to that when you get this. I made a question just for Tony. He just went to the bathroom. We'll take a look at this once. We're talking about the slope of a road. We call that the road's grade. Grade is commonly expressed as percent, like a 10% grade. If you're driving through the mountains, you'll see warning, 10% grade or something like this, depending on how steep it is. The steeper the road, the higher percent. The formula here to calculate grade is you do the slope, the rise over the run, and then you multiply by 100 to make it a percent. That's percent grade. Let's try this out. Tony, the road warrior, Iron Child, is driving his truck on Trans-Can. There's a sign indicating a 7% grade. What's the slope of the road? What is the slope of the road as a fraction and as a decimal? Okay. What does 7% mean? Like, what is 7% out of 100? Does percent means out of 100? You remember that? I keep pointing at you because I know you didn't work with me last semester. I'm not picking on you. Okay. So the slope is 7 out of 100. Okay, and that's as a fraction. How about as a decimal? How do you make 7 out of 100 a decimal? Can you do it in your head? You could divide it if you can't do it in your head. I'm sorry? Yep. Oh, no. You have important things to say too. You probably have important things to say. Maybe you know how to change any fraction into a decimal. Okay, 0.07 is what you got to get. Yep. Okay. What is the angle of elevation of the road now? What's the slope as a decimal? 0.07. And if we remember here, if I have the slope as a decimal, like this, can't I just say that's what the tangent is? and then I can undo it with my calculator and get the degrees, the angle. You guys follow what I'm saying? We're building this on the other problem. So find the angle of elevation. I'm going to call it theta. That's a Greek letter, but that's what we generally, it's popularly used for angles. It doesn't have to be, it could be x, angle x. Then I'm going to say tan minus 1 of 0.07. And then I'm going to see what my calculator gives me, or you're going to see, actually. You go for it, kiddies. And we get what angle? Did you get an angle? Did you do this one? And what did you get for an angle? Did you use 0.07? I like to round my degrees off to just 28. There's 4.0 if you want, 4.00, right? I just call this one 4 degrees. Be reasonable, don't go 17 decimals. Now, that's the problem. Now, one last one before the big weekend coming up. It's the end of the class in a few minutes. No, I said big weekend. It's a 2-day weekend, but it's big because it is what you make it. No, it isn't a long weekend, just a big weekend. What's the percent grade for this section of road? It goes up 150 meters over a distance of 3 kilometers. Now, first of all, 150 meters is one system. Kilometers is in another measuring system. How can we, well, it's not a different system, but a different unit. How can you change kilometers to meters? Do you guys know? What happens in that example? What happens? I have a poster up here. It's hard to see though. It's faded actually. But what does kilo mean? It means 1,000, okay? So if I said you traveled 1 kilometer, how many meters did you go? 1,000, right? If you traveled 3 kilometers, how many meters? 3,000. Now, anything you can get more complicated, and the three of you at the back just did a conversion unit halfway through your Math 10, right? Well, chapter 3 or 4. So you got to make sure that your units are the same. 3 kilometers is 3,000 meters. 150 meters, then they're both in meters. They match. Does this make some sense to you? It does? Okay. What do you mean? You could have made the meters 150 meters into kilometers. It would have been just fine, as long as they match. And you're good with this? You good? Okay. So, percent grade, let's go back. What is percent grade? It's the rise over the run, it's the slope, times 100. So I get the rise over run. It goes up 150. So 150 over 3,000. Then I multiply it by 100 to make it a percent. Alright, you guys are going to tell me the answer. Then our books will be closed. Well, we'll let you in this 2 minutes, right? And if anyone who's new wants to start, the 3 of you, because you were in Math 10 last, if you want to start a file folder, I'll get you one. I'm going to sit down with Tatiana and get one. What is the decimal number here, Shayna? Lloyd, I haven't heard a thing from you all day, actually. What is your decimal number? Oh, you're terrible, man. You're waiting for the lady to do the work? You got a number for me, man? You don't, do you? Okay, tell us, Shane. What's the number? 5. When you multiply by the 100, you get 5% on the grade. Tony, you were left and I was doing this problem dedicated to you. The first sentence. Okay. Now you guys have all the tools, and that's a lot, to look back on the assignment as you look through the assignment and do these questions. It all comes from those, okay? And there, as it gets there, you see that later on the last page? This one's a doozy. Don't be shy. Give it a try. There's some tougher ones. There should be. You guys, there's some tough stuff. I'm going to